Спасибо. So the classical PRE formula is multiplication, say, the column Schur function times arbitrary Schur function is the sum over all Young diagrams containing mu over S lambda, and similarly, if you multiply the row Schur function, it's again the sum over all diagrams containing mu of S lambda, and here the sum over lambda containing mu such that the complement is an R vertical strip, and the same here, but only it's a horizontal strip. And recall that as column is the elementary symmetric function ER, and Schur for the row is the complete symmetric function HR. Yes? We are going to prove the following formula. ER times P mu, Macdonald polynomial, is the sum over all the diagrams lambda containing mu of P mu with certain coefficients, and again the sum runs over all diagrams such that the complement is an R vertical strip. But the coefficients now are not ones, but something, and this something looks rather appalling. This is the product of certain binomials. 1 minus q to the power mu I minus mu j, t to the power j minus I minus 1, and the product over 1 less than or equal to I less than j less than or equal to n, and n is the length, oops, mu, okay, and then 1 minus q to lambda I minus lambda j.
Единственное, вот этот кусочек доски может не попасть на запись, я
well, you know, there is a story about the hiring committee working where they receive like 1,000 applications, and they need to choose maybe like 10 candidates for a short list, and they're somewhat terrified by this 1,000 applications, and then the head of the committee takes this heap of applications and disposes of 600 of them, and everybody is surprised, and he says, well, we don't need losers. So the same here. Okay, so this is the explicit formula, PRE formula for multiplication. Yes, and well, you may wonder why such a long formula, but let me say a few words of apology for this formula. So it's called bispectrality. So what does it actually mean? Well, say let R be 1. You remember we had this McDonald operator, and in fact many of them, they all commuted, and the simplest of all was the first one. So we first proved that the McDonald polynomials were eigenfunctions of this first McDonald operator, and then deduced that they were also eigenfunctions of everything else, and hence they all commuted. So again, let's start with the simplest case, R equals 1. And let's introduce the shift operators. Ti on functions on the lattice z to the n. Just Ti f of a certain vector, say lambda, is f of well, maybe let me call it lambda 1 and so on, lambda n is f of lambda 1 and so on, lambda I plus 1 and so on, lambda n. Okay, so the same shift operator, but now it's on the lattice, on discrete lattice. And then we can apply it to partitions. But again, sometimes it can happen that after addition of 1, our sequence becomes not partition anymore. Still, well, we can restrict Ti to partitions of length less than or equal to n inside z to the power n. Just if lambda plus 1i is not a partition, then Ti f of lambda is 0. Okay, so we just consider a certain cone inside Zn, and the shift operators sometimes go out of this cone, but never mind. Our functions are supported on this cone. Okay? So now this claim of, for example, this claim, say this, says that the collection of S mu where mu is a partition. Is an eigenvector of the most stupid operator, the sum of all, well, t1 plus so on plus tn with eigenvalue S1 R, that is just E1, that is just x1 plus so on plus xn. Right? Pardon me? So R is 1 here. Just 1. Here? Here? What does it mean? Well, it means that yeah. Length less than or equal to. Yes. Okay. So it means that our function, well, again, the same can be said about McDonald polynomials. So P is, so to say, the universal McDonald polynomial. So it's a function of x1 and so on, xm, and also lambda 1 and so on, or maybe mu 1, mu n. Okay, so this is what I'm trying to explain right now. So we consider a function of two n variables. Of them, first are continuous variables, our beloved xi, and the last n are discrete variables. Okay, and well, our functions are symmetric in these variables, but these variables are constrained to be decreasing. Okay, and then as such, we know that this operator t1 plus so on plus tr applied to p is just, oh, no, sorry, then here it's, what I want to say. Well, the operator here is more advanced, so it's how to say it? The sum of t, those coefficients psi prime t r. Okay, for r from 1 to n, or maybe better I, like this. Okay, so then if you apply this operator, and psi prime is the function of well, pardon me?
Should be p lambda there.
Just one moment. Here p lambda, yes, and here, well, lambda plus 1i over lambda ti. Okay, then this operator, let's call it D n1, takes P well, maybe I should right mu here. Sorry, but how to say it? Maybe I should write nu here. Sorry. So it's some function on the lattice, and I apply this to P mu, and then it will be again P mu, but multiplied with x1 plus so on plus xn. Well, again, it's just this P, the universal guide. Okay, so this P is function of two n variables, and as well, this function satisfies this difference equation. Well, this is you remember we had this other operator d1n, and it was the sum of t q xi with certain coefficients, and these coefficients they depended on x. They were certain functions of x. Well, a I over x q t. So they were functions of x. And the same here. The coefficients here are functions of nu. So the value of this function at arbitrary nu is just what I wrote. So you add 1 to the ith part of nu. Okay, then you obtain this pair. You write down this product. Pardon me?
P is independent of
P is this universal polynomial. Just this one universal polynomial.
Вот эта верхняя сумма связана вот с этой суммой в форме двери.
It is just this.
Но тут же может быть много слагаемых, побольше, чем n.
But I'm only talking about this first operator, when r is 1. When r is 1, the vertical 1 strip is just adding one box.
Yes.
Okay. And certainly there are higher operators when you add 2 or more boxes that form a strip. Well, so P is just the collection of all Macdonald polynomials. Any Macdonald polynomial P lambda is a function of x's, but it depends also on its index lambda. And this way it's a function of two variables, x and lambda.
И еще второй момент, значит, ню все-таки как оно у нас берется? То есть мы изначально фиксируем ню или просто...
No, nu is an arbitrary partition. And you write a certain function on the cone of partitions by this formula. And then you consider a linear combination of our shift operators with those coefficients. These are functions on...
Вопрос тогда получается у нас, когда мы берем, то есть мы можем взять p-μ, как произвольный, дальше взять psi штрих от μ.
Well, psi prime depends on two things.
Да,
Yes.
Здесь в контексте, что мы не фиксируем. И получить, собственно, что-то.
Well, this will be another collection of polynomials, but this collection of polynomials will be the same Macdonald polynomial
То есть
multiplied by E1.
То есть у нас замена ню просто создает автоморфизм между...
Yeah, just add one box.
И нет, замена ню в плане, мы зафиксируем ню штрих, если вместо ню, то у нас это задаст просто автоморфизм между... Не автоморфизм, извиняюсь, изоморфизм между вот этим самым... Короче, да, между образами вот этих вот двух операторов, или как?
I don't understand what is new prime.
So we fix new prime.
No, okay, you can speak in Russian, it's fine, but that's not the reason why I don't understand.
Ну, просто тогда не очень понятно, как у нас, то есть мы можем поставить вообще произвольный ню, у нас на выходе получится то же самое всегда.
Well, according to this formula, yes. Well, this formula is just literally that. For r equals 1, yes. But then you certainly can write down operators drn. They will be the sums of psi, well, as you suggest, nu prime over nu, and this nu prime will be obtained over all subsets of cardinality R, T, the product of T I over I in this subset. So it's sort of elementary symmetric polynomial in those shift operators. Okay.
Это было отступление или как вы кто доказываете, то, что слева написано?
This.
Да.
But this is just, once again, this is just this formula. I just rewrite this very formula in this fancy way.
Как там?
А new prime как получается?
New prime is just new prime j is new j if j is not in I, and new prime I is new I plus 1 if I is in I. So I just add boxes at certain rows according to this subset. And then again, this formula says that the Rn applied to P is just elementary symmetric function of x times P. So in other words, this P is the common eigenvector over all drn with the eigenvalues we wrote down last time and before, and over all drn with eigenvalues er of x. Okay. No, why? No, by no means. It's vertical strip. So in each horizontal line there is at most one. So these are really elementary symmetric polynomials in, well, without those coefficients. The sum would be elementary symmetric polynomial in shift operators. Okay, so the situation is very, very symmetric. We have this master function, Macdonald function, in two variables, x and partition, and then there are difference operators in x's, and the eigenvalues are functions of lambda, or else there are difference operators in lambda, and the eigenvalues are functions in X. And that's what this is called bispectrality. So I have two different integrable systems, one in those variables, one in those variables, but they share the common eigenfunctions. Okay? Well, in fact, there's one eigenfunction in two variables. The similar things happen in all the possible variety of situations. So, for example, these could be both discrete variables with difference operators, or both continuous variables with differential operators, or multiplicative shift operators, or additive shift operators, whatever. Okay, and in fact, when I talked about some quantum mechanical dictionary, then most straightforwardly, quantum mechanics applies to functions on the lattices. Yeah, because that's the meaning of the word quantum. Say there is like minimal electric charge, or minimal distance, or minimal time interval. So the universe under, well, in the very large zoom looks like a lattice. And in fact, this idea was explicitly stated by Riemann, like almost 200 years ago, before Max Planck or Einstein or whatever. This conjecture that the universe could be discrete in the very large scale or small scale, I don't know, but under very large zooming. This idea is written down by Riemann. Yes?
Может быть, глупо, просто как мы все-таки поняли, что, собственно, вектор d с двумя черточками? Вот это красиво.
Yes. But this is just this formula. No, this was just an announcement. Now I'm going to start proving this formula. I'm not sure we will succeed today. It's a difficult formula. But just I wanted to say the meaning of this formula. Okay. Well, we need the following definition of a certain evaluation homomorphism u lambda from our field of rational functions in Q and T. U lambda is from polynomials in x1, so on, xn, with coefficients in this field, to the field itself. Namely, xi goes to q to the power lambda I, t to the power n minus I. Okay? And now let me recall lemma 13 from the last time. So it says that if the length of lambda was at most n, and we have n variables, then the McDonald operator with a generating function, generating variable x capital, applied to p lambda, McDonald polynomial is the product of binomials 1 plus capital X, q to the power lambda I, t to the power n minus I, times p lambda. Okay, this we proved last time, and from this we deduced that all the higher McDonald operators commuted with D1, and okay, so now this implies that when we apply our McDonald operator to polynomial p lambda, this is just the evaluation, this u lambda evaluation of the elementary symmetric polynomial ER times p lambda. Well, this is just the definition of elementary symmetric polynomials. Okay. And then let's recall the eigenvalues. Maybe not the eigenvalues, rather the definition of McDonald polynomials, Dr(n). So what was our definition? Dr(n) was the sum over all R element subsets over certain coefficients. The product of Ti okay, and the coefficients Ai was the product t to the power r, choose 2 over all elements in this subset, and all elements out of this subset, txi minus xj over xi minus xj. Okay. So this is just by definition of Dn. Okay. So now, if we look here and there, we see that the evaluation of elementary symmetric polynomial times p lambda is the evaluation of a sum over all R element subsets of AI, product of the difference operators, p lambda. And we can now compute the evaluation of the right-hand side. So evaluation of AI is can be rewritten in the following way. The product of xi to the power to t to the power theta I minus xj t to the power theta j over xi minus xj, and now theta I is 1 if I lies in the subset and 0 otherwise. So I just rewrote this formula. So, sorry, it is even before the evaluation. But now I can evaluate. And I get the product over I less than j, q to the power lambda I, t to the power n minus I plus theta I, minus q to the power lambda j, t to the power n minus j plus theta j, over q to the power lambda I, t n minus I minus q to the power lambda j, t n minus j. Okay. This is just the same. I only, well, I had a product like this, and I rearranged it as a product like that. But it's just a tautology. Here? Well, it's just the definition. The McDonald operator is just this, and I know that P lambda is an eigenfunction. So in the right-hand side, well, maybe I should erase U lambda first.
Вообще, да, справа. Получается, никаких иксов вообще нет. Сейчас.
No, sorry.
Справа надо стереть просто.
Yeah, maybe that will better. Yeah, sorry. Okay. But still, I want to evaluate the coefficients. Well, just because this is the eigenvalue of the McDonald operator, and this is the McDonald operator itself. Yeah. Just this eigenvalue is the evaluation of ER.
Что не так сейчас? Что не так сейчас?
Все записано верно, непонятно.
I only wonder.
Сейчас не получится то, что нужно, если, например, мы лямбда применим к лямбда слева, и тогда это можно будет на все это навесить справа тоже. Если лямбда будет написано лямбда от R, то лямбда от лямбда, и справа будет написано лямбда от всего. Будет верно?
Maybe, well, so this is true, and this is also true, and maybe that's all what I want to say. Okay, so if I just evaluate those coefficients as stated, I just get this formula. Okay. So next lemma says that the evaluation of the coefficient is non-zero if and only if mu plus theta. So theta is this function. It's not a partition at all, just some zeros, some ones, but this is mu1 plus theta 1, mu2 plus theta 2, and so on, mu n plus theta n, if this is a partition. So if pardon me? Here it's the indicator of the subset I, indicator function of subset I. So if the evaluation is 0, then there is a pair I less than j, such that mu I equals mu j, and I minus j is theta I minus theta j. Then the corresponding factor of the numerator will vanish. But we know that the difference is at most 1.
Как это мы получили, что когда mu и равно mu
only here it's lambda, there it's mu, but otherwise.
Ну, на 0, когда какой-то числитель 0.
Да.
А тут числитель был 0, нужно, чтобы q в степени равно q в степени равно жить.
Я просто не понимаю, mu какое отношение к числителю имеет.
Oh, well, let me write this. Is it better now? Great. Sorry. So we conclude that j must be I plus 1, theta I must be 0, theta j must be 1, and hence mu I is equal to mu I plus 1, and mu I plus theta I then is less than mu I plus 1 plus theta plus 1. So mu plus theta is not a partition. Here? Just because it's an indicator function. It's either 1 or 0. So any difference is at most 1. Huh? Oh, sorry. It's at most 1. Sorry. Sorry. Fine. Pardon me? Here? Well, if they're equal, then there's nothing to say. If they're equal, then there's nothing to compare and nothing to.
Получается у нас... Из чего мы получили, что и минус g равно θ и минус θ?
Just from we must this to coincide with that. Okay, and conversely, if mu plus theta is not a partition, then there is I, not the last one, such that mu I equals mu I plus 1, and theta I is 0, and theta I plus 1 is 1. And then again, the numerator will vanish. Okay, so now let's give another definition. So let mu be a subdiagram of a new diagram, and they all have length at most n. And the complement is a vertical strip. Then we define the coefficient b nu mu as t to the power n of nu minus n of mu times the product over all pairs I less than j of 1 minus q to mu I minus mu j t to the power j minus I plus theta I minus theta j over 1 minus q to mu I minus mu j t to the power j minus I.
Сейчас это произведение на то, что мы на θ умножаем.
Pardon me?
Последние две строчки это одно большое произведение, которое просто не поместилось на доске. Да?
Right. This times that. And this is just the evaluation of AI, where I is the set corresponding to this vertical strip.
Это значит тоже 0 и 1, да?
Yes, it's a vertical strip. So
Понятно.
okay. And now let's apply the evaluation to our equality. Okay. Okay, maybe we will label this formula somehow, like. Okay, so the sum over. Pardon me? This one. Well, I just didn't write it. It's the usual. It's what we had before. This is the usual McDonald operator. It is the and p lambda is eigenfunction with this eigenvalue. Yeah, to p lambda. Yeah. Applied to p lambda. Mm-hmm.
Потому что эти операторы T у x и T.
Yes.
Они как будто...
Yeah, they're also, everything is here, yeah.
Нет, там понятно, вот в этой формуле, которая обведена.
Yes.
Куда они там исчезли?
Where are they? So when I when I evaluate the right hand side and then multiply by q, I just acquire extra box here. So the sum is over all super diagrams. Okay.
Куда они исчезли? То есть, когда мы угол поменяем кали, то получаем вот эти b.
Well, they are the products of shift operators, and the products of shift operators under this evaluation result in changing u mu to u nu. Okay. And well, furthermore, if we evaluate at 0 polynomial p lambda, we don't get identically 0 since for specialization q equals t, the evaluation p lambda becomes the sure function, and the evaluation becomes the sure function of t n minus 1, t n minus 2, and so on, t1. And this is not identically 0 by some exercise that you had in winter probably. Okay. So finally we set renormalized Macdonald polynomial is p lambda divided by this evaluation, which is not 0. Just because, well, to prove that it's not identically 0 is enough to show this for any specialization. And we specialize Q to T, and then Macdonald polynomial specialized to Schur functions. And for Schur functions, we know that this does not vanish identically. Okay. So now the main result today is that for any lambda and mu of length at most n, there is certain symmetry. Evaluation of renormalized polynomial Q mu is the same as mu evaluation of renormalized polynomial P lambda. And also, if we multiply the renormalized polynomial P sigma by elementary symmetric function, then this is the sum over all nu of those coefficients b nu sigma p nu tilde, and this is the desired PE formula. So if you rewrite it explicitly, you get what I stated in the beginning today, and the sum over the same set. Okay, so let's start proving this. The proof will proceed by induction. And the base of induction is, so it's induction not just in the dominance order, but in the size of partition 2. So A is clearly true for the 0 partition and arbitrary lambda. Well, because the evaluation of the zeroth renormalized Macdonald polynomial is 1. The polynomial itself is 1, and the 0 evaluation of P lambda is also 1. Okay, and now we'll proceed by induction. in mu. So assume that everything is proved for any lambda and any pi such that either the size of pi is less than the size of mu, or they have the same size and then pi is dominated by mu. So let R be an integer, and assume that mu r is bigger than mu r plus 1, and sigma I is mu I minus 1 for all the smaller i's, and we set sigma I equals mu I for I bigger than r. Okay. So we'll prove our theorem for this sigma. Then we know that the leading coefficient, or maybe not coefficient, but term, the leading term of the renormalized polynomial p sigma is x to the power sigma, and the leading term of ER is just the product x1, so xr. Yes? Pardon me?
The first sigma is what?
What is sigma 1? So if r is bigger than 1, then certainly mu starts with mu 1, mu 1, mu 1, and so on, and sigma 1 is also mu 1. If r is just 1, then sorry, moment. Yeah, I think I made a mistake. Maybe I want to say this. Sorry. Pardon me?
Ну, в театре заявлено 2 перестановки лямбда и мю, а мы
Mhm.
еще какая-то.
And lambda. But sigma certainly is smaller than for mu and lambda, sorry. Okay, so we see that the leading term of p sigma tilde times er is x to the power mu. Yeah, so we decreased the first r parts of mu by 1, but then multiplied by this x1, xr, so we get this. Okay, and so we conclude that ER times P sigma renormalized is the sum over all nu at most mu, certain coefficients C nu, P tilde mu. So for some coefficients C nu. And now from this formula, sorry, no, I only have to erase something. Maybe let me erase everything else. We get for any pi that evaluation at pi of ER times evaluation at sigma of P tilde pi is the sum over nu, b nu sigma u nu of pi of p pi renormalized. And again the sum over all nu such that the difference nu and sigma is a vertical R strip, as always. Yeah, that's just because of leading terms. Yeah, okay, so let's. Yeah. Okay. just because we know the leading terms in lexicographical order. The sum over all nu smaller lexicographically than mu. And this is okay. Let's also call it something star. And this. Okay. So now if pi is of the same size as mu and pi is dominated by mu, then by our induction assumption the evaluation of renormalized Macdonald polynomial is symmetric. Okay, since we know that sigma is smaller than mu in size, so the induction assumption works. And also we know that evaluation at nu of renormalized pi Macdonald polynomial is evaluation at pi of renormalized nu for any nu less than or equal to mu. Again, by induction assumption, for pi less than mu or nu less than mu. But otherwise, we must have pi equal mu, and then it's tautological. So hence this formula right here implies that the evaluation of ER times
Эти все меньше или тоже лексикографического порядка? Больше,
but for lexicographical order, I don't even need to assume that the size is smaller. Yeah. Okay. Yeah.
Почему там в левой точке написано otherwise равно
Because, well, either pi is smaller or nu is smaller, or they're not smaller, then they must be equal to mu, and that's it.
А почему не может быть больше?
We yeah, we assume that pi is at most mu, nu is at most mu, so either they're smaller or equal, and if equal, then it's tautological.
Порядок тут лексикографический.
So everywhere, yeah. Okay, so we apply this star formula, and we get that this equals the sum over all super diagrams be nu sigma u nu u pi over p tilde nu. Okay, and now apply the evaluation u pi to that formula. We get evaluation at pi over er p sigma is the sum over all nu less than mu c nu u pi over p tilde nu. Okay. Now comparing these equalities, we get what we want, that c nu is b nu sigma. Well, if nu without sigma is a vertical R strip, and zero otherwise. But in order to compare those equalities, we need to know that those polynomials are linearly independent. So we get this quality modular the linear independence. So we will later check that the matrix of evaluations u pi over p nu, where pi and nu run over all partitions smaller than mu, basically graphically, that this determinant is not zero. And then if we know that they are all linearly independent, then we conclude that the coefficients are as desired. Okay.
What do we need to know about the linear independence?
Pardon me?
С чего мы должны понимать про линейную независимость, что конечно коэффициент?
But if just subtract and we get 0. So if the vectors are linearly independent, then our coefficients are 0. Otherwise, not necessarily. Okay. So this formula became what we wanted. ER times P tilde sigma is the sum over nu B nu sigma P nu. And this is part B of our theorem. But now the time is through, so maybe let me stop now and I will recall the necessary notation next time and we'll continue. But the hardest part is proved. So sorry, I was so slow. Thank you.